is Liz's, and she made a table, and she uses this with her fifth graders?
First through fifth.
First through fifth.
Yes.
So tell us a little bit about what you were thinking when you did this.
The T-chart or the problem?
Well, like if I was looking at an answer, I would want to see parts where you're arguing what does the 2n stand for
Sure.
and what does the n plus 1 stand for.
Sure.
Okay.
So in the picture of the toothpicks, I counted toothpicks. I didn't count the square. I didn't think of it in squares. Okay. So I counted the number of toothpicks across the top, and that was the same number as the number of squares. And then...
So how many of those toothpicks are there on the top?
For which one?
Just n of them.
Oh, n.
Okay. So that's one of these n's there.
Correct.
Okay.
And then you have a second set going across the bottom, and that is n.
All right, those toothpicks should be the same size. So there's n of them down here.
Correct.
Okay.
And then when you put the vertical toothpicks in, separating it out and making the actual squares, when I counted them across, there was one more than the number of squares that were made.
Wait a minute. So
And
like,
so that's n plus 1.
so like in this case, you're saying that there are 1, 2, 3, 4, 5 on top,
Yes.
5 on the bottom,
Yes.
and then
6 going across because that's one more than the number of squares or the number of toothpicks across the top and bottom.
oh, so that 6 really is 5 plus 1 because it's
Yes.
one more than the 5.
Yes.
Okay. Then what the heck is that T-chart?
Well, we call that an expanded T-chart, which then kept track of the number of squares, and then what's happening. That's where we see, like I see the pattern that I'm making, and then shorten it up to the number of toothpicks that it took to make each one as you increase the number of squares.
To use kind of an expanded one to help students see the structure. This is a really nice tool, and it's a focus on structure. So when we say write for structure, that I think this is like a picture of what it would mean to write for structure. So when I finally am going to get good as a teacher, I'm going to do more of this, and then my kids they just see it. They see structure there.
I used to never think this way, and the more that I get to do it, the more that I start to think this way. The way that you get your brain to do those things is to try it, and try these kind of problems, and make yourself say, well, what's another way I could do it? Oh, I see it this way. Well, let's make myself try another one. And then all of a sudden, I start to see it in those ways, and I didn't used to, and it gets easier. And that's what that growing brain. So when I tell it with kids, that idea, Liz. So equivalence being that idea of how those things have in common, but that as we expand them out, getting that idea of how each of us saw those different things.
But the language right there is a connection. So Liz, and what you're saying is connecting the picture to the formula or the picture to the algebraic expression. And so that's why expanded tells tells the story about how you counted it as opposed to just the number. If you say, I see 13 squares or 13 toothpicks, that's one thing, but that story isn't as rich as when you say, I see 1 plus 3 plus 3 plus 3 plus 3. Or I see, what the heck was that, 2 times 4 plus 4 plus 1. I mean, it tells a story.
Well, what I appreciate about what you just said is, and what whomever said you didn't see it that way, when we come together and share strategies, the people at my table had different ways to see it that I would have never thought about either. And so by working together, it pushed me to figure out how to generalize what they did versus how I generalized. And if you actually took the ways that we saw them and then they simplify to the same equation, but then it loses the context of how I saw it.